a numeral 1069, which also reflects a prime number 1069. This number-numeral relationship will become surprisingly, like shockingly important for something so trivial. But I'll leave that to later. And so effectively, we'll say codex over here, and just so I don't have to always switch it, I make IES, AES, which has basically dangerously bypass everything sandbox. Let's just go. We'll introduce sandbox gradually, but for now, the first thing you need to have is sandbox to just have a number of flows that have ideally some variety of structure to them, right? The common structure is you plan first, you research, then you plan, then you execute. One variety I particularly like, described as like sort of Socratic, right, is the or like asking leading questions can have the certain types of confabulation, antimatters, but in this case, you're actually very technical about what you're asking, making sure every step of the way. In addition to advancing with the query, you also proceed to verify that some immediate competency is still maintained. Like, is this thing completely a vegetable or is actually doing something useful and understands the context? And so this is up to you as a skillful kind of appreciator of human consciousness to decide what it looks like. If that's too much, basically, you can start with a different mode. My favorite one is random. It's random walk. Okay, so I said that there's some skills involved. Let's see how we can set you up for success right away. So you either get Toad, or you get one of the Codex or Claude or Gemini or Kimi or literally anything that supports ACP, and you'll be probably good to eventually use the code from this and basically enjoy it for your own instructions. One of the rules of this will be like no Git, hashtag no Git, right? So we're going to just do anything about Git. You can do Mercurial if you're a particular kind of person. You can do Darks if you like Haskell, Joule, God knows what. We're going to use something that's a little bit Git compatible and has a bit of a tooling called JJ. So JJ, it's a thing. It's remembering how to computer again. Yes, UVX JJ. There we go. One command, UVX JJ. Error, lovely. Python issue, remember, no Python. Okay, so if not Python, what is there? Well, it's kind of a grandmothered into my system is this thing called Bashka, BBE, and so it's a RAPL, right? And RAPL it's not a language model. It's a kind of a special environment for carrying out operations of this kind. So now look at those parenthesized, but you wouldn't believe it, but you are looking at a string diagram. Yes, I'll show you how later, but I feel like it's a very important thing to say that what happens here, and the way to think about this kind of code, is that it's rewriting these things in between these parentheses into corresponding values. If we had the prime index, so the prime number like 1069, we could say prime at that index, and that would replace this entire expression with that number, which it has been all along, according to this kind of like order invariant evaluation of these terms, whether you invalidate one and then add the six, so 5 to 8 dash arithmetic. It's the hardest thing. And so then that would be 6. And if you wanted to do this as a this first, say this is 5, and then you add 1, then it's still 6. And so that kind of that makes it very much like a string diagram in some sense that we can follow. Closure rocks bash features. Maybe let's see. Some things just are, and most things in computers, digital computers, are just what they are by necessity of like systems that created them, right? And so there are a lot of times what they'll have all these like OKRs and different types of site Kanban, Scrum, all that nonsense, right? The iteration was slow, and eventually, by the time it was actually important, you would go on your Thanksgiving vacation, and things would just be like, kind of, okay. And then the critical stuff would bite you, so you eventually fix it. So a lot of this crafted and intermediate noise is going to be and is being ripped out. But to maintain like this continuity of legacy systems working with the current systems, what you notice is that the interface, the syntax, the way we discuss concepts and relationships between different systems is at the boundary between these systems. So the interface is structs over some increased component. And so here is Cloud Code. I say, okay, one of my favorite things to do in Code is confirm our tools by enumerating ones that can even vaguely help us determine precisely and correctly the index, the order, the position of the 1069 drawing in the collection of positions, 0 and 1 indexed, right? And if it's Julia, it's going to be Julia's simplex.gl. Or just kind of a crazy thing to say here, because like, what is the semantics of that, right? In this case, I'll say, okay, fine, we'll give you a bit of Python, so just so you can have fun. I'll show you my package called HiMLX. Okay, so HiMLX is a package I made. It's a machine learning framework, right? So it's machine learning framework with a really stupid, almost like degenerate, abandoned ideas. Like, let's take MLX, which is this like accelerator, sort of metal and other silicon specific way of doing the same thing that JAX is doing, or even TensorFlow had a thing for doing, but AutoDiff over, in this case, while the JAX itself has a Python kind of like component to it that looks like NumPy, that is only a kind of a syntactic shell around otherwise operations that involve these things like arrays and tiles and all kinds of interesting things in parallel. So why not use this HiMLX as a kind of thing? So you can use this with many different things. You can give your models a voice, and what you can do is actually, well, let's see, backtracking is generally the ways. Let's see, the Bashka is going here. Nice. So this here is an on-the-fly Lisp program, right? This is probably not a program. Well, this one in particular, I probably will be running for a while, but I think other programs that happen like this will not necessarily be programs you want to reuse. And so one of the first like ideas is to let go of this like long iteration cycle and getting your computer to do what you want by the use of precise correct code. It's very different from a language model. You can think of this as kind of like interpreter with, I hate the idea of Copilot, first of all, like, including the first versions of Copilot would probably be like very much dead if we were relying on flights for this. And so I think that level of security is unwarranted, but it's more like a sidekick or something called Cojan, that's some sort of flexible way of saying, okay, I'm lazy, I just want to say what I want. And here I was really precise because I knew precisely the derivation I was doing. And I was following this pattern where I was testing, right? Where I didn't precisely say, in fact, I kind of like changed the order of 0 and 1 index to see something that I know for a fact, having done both and like even read the spec sometimes, or pips or whatever, was 0 and 1 index being Julia or HiMLX or Python by inference being correctly assigned to each position, even though they're out of order. And as you can see, yes, perfect. There's this reasoning going on. So in context, just decided like basically, okay, we have this practically, I have this sort of Aristotle theorem prover. Okay, there's something I want to show you. And so the idea is like, yes, you can install a Hello World MCP that lets you use Stripe or something or order pizza on Uber Eats. But I find a much more fun onboarding experience is to find a system that's already enabled in terms of capabilities and just use that to customize basically and infect or spread to or propagate into the worlds of systems that haven't been infected yet with this kind of almost like an organism at that point, less so a software engineering kind of endeavor, more a cultivation of correct streams and basically at the end of the day, simply computers doing whatever the fuck they want them to because they serve us, not the other way around. So basically, stop sacrificing to pain. If you feel pain, you feel suffering, you can't make it stop, then burn your computer, destroy it with like bricks, whatever, microwave it, because it's not how it's supposed to be. Right? And so the idea of this like joyful subversion is to say, we no longer abide by the nouns given to us, the categories of things that existed in the old world. And it means being this like radically open-minded thing about what not to do, I think, in pursuit of simplicity. And there's one thing called referential transparency. So I want to give you new words. I think this will be a crazy thing to watch. And I'm going to assume that this will be parsable, but what will happen is that eventually enough of people watching or coming across this, maybe subsequent things, will paste it into the enough models. And enough of those Lisp primitives are parsimonious in the sense that they are not very big to state the fundamental rules of it. Even if you learn them, representation will be compact. That means that it's more likely that in more contexts they will also propagate. So there's a certain kind of like a pressure, evolutionary pressure, syntax to become maximally expressive with greatest generality using least space. Ultimately, some sort of position. Okay, so here's code. This just became much better. If we finally feel comfortable demoing it because it's not like this exercise in rating and whatnot. So one of those things that we talked about is open telemetry and like basically how to bring these like practices from enterprise. And usually they don't happen because enterprise is better. They happen because they have lawyers and they really hate to be sued and the corporation and so on. So this stuff doesn't come from anything but necessity, right? So the idea of necessity as driving choices should be very interesting to consider from the fact of how most tutorials are done today, right? So today we say, okay, hello world, let's use this very simple library. And then you're like, well, what now? So you don't know what you don't know. And you say something, you want things. Maybe you hear about them on Twitter, somebody shows something, but you never quite fully, uh, kind of determine your own path, right? And so in this sense, it's difficult to imagine setting up tools will ever lead there. So I wanted to set some objectives for the session and do something real and useful. And I will hopefully remember to check messages, but if I don't, so be it. Basically, if we are successful at the end of this, we'll have some sort. Okay, so I said that we listed this, and then I talk about Svelte. So what's going on? Well, ideally, what we'll have is a combination of embedded, inline, or otherwise contingencies for different semantics of Symbolic expressions that begins very flexibly and very much adapts to the benefits of the platform it's on. So as I mentioned, there's high and low, so I'll say, okay, pull the latest trees that are, which is a syntax thing, having all these functions over here. Don't worry about them. Don't feel like you have to study them one by one or whatever. I spent 5 hours reading. No, the idea is interaction should be easy, and so that's why we need skills. But I'm showing you how to do this without skills. If you're starting from so-called first principles, or these first experiences of not having this, having had that big experience of seeing them before letting us be pedagogic about it. Like, I don't have to do these things this way. I could say, for instance, if it's saying the other side, it would be nice homage to dollar sign gets you stuff. You get stuff like AC set accelerator. Perfect. Very obscure skill. As I said, it's a biology kind of like thing, right? It's more like protein insertion sites, not so much uh, which version of GLP to use, even though that will inevitably cause things down the line. And so it's important to be aware that these things can happen. So here we have regular Babashka. So what is Babashka? It looks like Lisp, it looks like Clojure, but it actually uses Bash for scripting. And so the brave claim of hopefully a series of these things and in parallel is to say that it's sufficient to just have correct syntax and be very careful about handoff between different like substrates and runtimes for that syntax, making sure that while individual, like for instance, I have this other skill that we want to talk about, so which is to set the tone for the rest of it. So agency means sometimes breaking some things, fucking some shit up, and so let can go and like trailer-based skills are those that I wouldn't say it's like a polluting or security. Its goal is to help you do whatever you need to do, right? And that's unfortunately not like very glorified and luxuriously legal many places of the world. And so these will be a slightly subversive kind of like take that you can do things that used to be like very much pastime of like people who spend a lot of their free time learning reverse engineering by using IDA Pro or Ghidra or something like that. Now you can just say, okay, I want to reverse engineer stuff. We actually have a new So I want to reverse engineer Flex, say Flux, so I can make Flex. Remember, we'll keep coming back to the overarching objective. So I can do SNCS and some other things I have now a hard time keeping together, but I've posted about before, right? And so this idea that now you can actually take a buffer of your preceding interaction somewhere and use interaction time as the most important time to measure something about it. And you say, okay, deeper MCP, 69 of 9 messages, right? It's still self-involved. Why would you list your messages? You sent them already. But the thing is it really you? Or is it someone who had a different context and a much more divergent set of incentives, increasingly so as time passes. It feels like it's almost like a linear to go back and retrieve it. And if you have more than 7 plus or minus 2, it starts getting even harder. These other things can end that task. By close, so syntax closes this like the Z specifically, it's a different token. So this token over here, maybe it's closed, maybe it's closed. The tokenizer is no longer slept on because of Karpathy, actually. So that's cool. But from IES and control for messages of those who send one message only in this interval in between. And so you say, okay, don't want to have like serial yappers, they're already overrepresented in our data set, but you can set these like rather specific, again, driven by our understanding of overarching distribution. Like these are not intuitions you can actually get easily if you haven't been using it, but the bigger pattern is that rather than asking for one thing, ask for an entire class of things. So I've been asking for one message. Using skill because you press the MCP. So there's not a skill for MCP, right? This is not actually the MCP itself that helps you use the MCP, right? So that's kind of the missing part. Like I said, it's really about helping humans be less disappointing in how they take advantage of options given to them by systems they already have, much less extending them, right? So the idea is we have this moment where in many parts of the world, and by many parts of the world, I mean San Francisco, many things have accelerated beyond the ability of other people around the world, like people in New York, people in Bangkok or something, to take advantage of, right? So, not to be in any way dismissive in those places, because eventually we'll equalize. But now there's like this out of equilibrium thing, and you know where the system is going, right? So how can you benefit from this? By empowering others. Honestly, that's my conclusion on this, is that the models themselves, the systems are not as important as what humans will be able to do with each other, to each other, for each other, within this new shared real-time system. And so training humans has become the reason I've decided to do what's really is not the most comfortable thing, is to expose the thing in this like way to the internet gradually, but then suddenly, and then keep enough of it private so that people who participate in some way that is skin in the game get to have the confidence that they will not be ruined and it will not be all for nothing. So we'll talk a lot about cryptography and encryption and time travel and things like that. But okay, so let's stay grounded. I like to think about sort of like bounded intervals. And so I want to set like some random. So if you don't want to get rid of time fully, because you don't have seconds, whatever, making the interval random is an interesting choice, right? And so there's this idea of, there's thermal, which is this package in JAX, which means I can make it into a high JAX package, JAX version. So high thermal, we say hypothermal, because it's just a bit, anyway, flip aside, like hyper, there's high, seems to get higher. It's just like a little layered thing, but really we just want to have it. Oh, the United States bash. See, one of those things I do, right? This is very security is starting to hit us. No, even though this is set to bypass permissions, right? Which is great for things that you actually trust. So take it from this layer of this like shitty one-man Python code base with some widgets to support an even shittier underspecified protocol with many holes to something that generations of computer science and security researchers have been using to do access control and permission like widgets to be executed, authentication or authorization to do something. And so in this case, I said, okay, never use bash, always use the bash code, right? And so how to do that? As you know, I'm not actually editing my own configs like how you probably would do. So I would remember it's the longevity house where we used to both reside, and so started. And so I wanted to say that this is one of those things where before you'd be having even more suffering, and naturally people who are sane people would see this like, oh wow, suffering is now different. Let me take this suffering. And no, they basically was like, I'm already suffering, why should I suffer some more? And then incur risk, right? And so this is not something I start with. I'm not actually telling you to edit your config. What I'm recommending you do is get a system that's capable enough to pick up this pass of a context of capabilities enactable from this system that I already have, or other systems like it, because there are plenty of them, or barring your risk tolerance. And see, it's already talking about C. elegans form. So it's like a kind of like an incredible coincidence. Why? Because it had found my collection of papers in the .bib file, and so you're like, whoa, wait a second, what would we be talking about some bloody something, but not this? Like, what is this? This is truly that thing what Stephen Wolfram says is like the source of irreducibles. It was there's this notion of computationally sophisticated observer. Computationally sophisticated observer, unlike me, will be able to like pass through all this and like directly identify these delimiters and figure out if you do it just right, if we haven't messed up and have some extra ones, then this is actually a very neat, very compact, and also traversable structure with some interesting properties that are better than strings, right? So this is somehow has a thing we call geometry, right? So the idea that the relations between these, the sort of the tree-like nature, the symmetries within it, will help us navigate this space. Seems abstract still. And all of this, in this case, is not a concern an average person has or should have, should our species make it to some better time. But what I really wanted to emphasize is what we're doing this for is to create structures that are very compact and do not require a lot of representation to hold on to, right? And so the idea, if in the context your structure is compact, and other structures are high entropy or like bigger, then once you're down, like whoa, wait a second, what? Take a deep breath. What remains is still that small compact structure, which is Babashka, right? But to really help these models to go to where you wanted them to go, I technically by default disable all default tools of all these default TUIs, partially because I want to use this for like red teaming and you really want to kind of like control some of that surface as much as possible in some way that you don't have to then like discover imperfections in the abstractive sort of like edifice of it's leaky abstraction and leaky abstractions, things that ruin your day when you started building on top of a shaky foundation and that self-dependency down sort of down the line came back to bite you and then your beautiful thing with it, computing or whatever the hell you're doing will not be feasible because your, I don't know, NumPy 32 is supposed to be a NumPy 64, and you're trying to shove this big thing into this like small thing, and then it just collapses. Like that's the kind of crap that happens in all layers of all software. So like, as much as possible, you want to be able to verify things, but not just like willy-nilly. You see the post about Haskell, you just verify like you prove one thing. And that's a practical approach, maybe it's tactical, but something that will maintain this very basic kind of like link from the primitives that are like the smallest possible piece to the systems they assemble into. So this compositionality aspect allows us to have one or two really good pieces of these MCPs. As you can see, this was struggling with correcting itself and trying to do it diffusion. So now we can actually have wireframers. It's a very difficult thing to watch this and then kind of like keep up, except, you know, so as you review this, maybe try it yourself, I wanted to show you how to make your life easier with graphs. Okay, so if you look at this Hymalux library I made, you can go to ZeekWiki, which is probably the best thing, in my opinion, Cognition has done or will ever do, possibly. It's just to make graphs more accessible to lazy people everywhere. And so what you can search for is skeuomorphism. I don't think I've indexed it before, but this year. And then you say yes. You say something oh yeah, Hymalux. So I'm trying to remember if I did. I hope I didn't, because if I didn't, yes, I haven't. Perfect. I can show you that you don't really need to have a browser anymore to do this. So I triggered this exactly sort of page from, in this case, Codex. So I'll switch to Codex on this side, and on the left side we're still dealing with prime numbers and a thermodynamic hypergraph model library, envisioning what the meaning of its transformations can look like in terms of wrapping its existing functions into a term rewriting semantics of parenthesized kind of like worlds, right? The world is this notion you will hear a lot from me because a lot of times to talk about phenomenally conscious states or anything like that with your computer being in the loop is hard to see where the context begins and ends. And so you can choose a little bit, mention this like abductive sort of way of doing things. It's okay, it seems like all of that is somehow part of the world. Therefore, I'll just like, you know, I'm confused, I'll say world. And that's the first approximation of what like worlding is about, is to say like we want to somehow have a thing that helps us capture all context that's necessary or possible to capture because I know. So to define a world, we need to define a kind of semantics of what a given world theory is. So like how to define what the world is, a valid world and invalid and so on. how worlds relate to one another. And then within that, there has to be some sort of a way of deciding which theories are valid as well, so like the next level over, and how to relate them. So the meta theories. The meta theory is kind of like a way to traverse theories, which then can form the formal foundation of something you verify. And so now it wasn't supposed to be a math talk, but this is kind of a talk about how I use it in the years. You don't really expect people to adopt this, right? You expect them to use the same approaches to build their own kind of like systems. And so, as you can tell, this is not really about MCP as such, right? It can do the same thing in RAPID without any language models. It could do some of them laid out. But if you recall, one of our objectives, oh yeah, there we go. So it goes to this repository. Debugger says it's not found, it isn't indexed yet. So it can use Note MCP, which is another browser, this is Note to request the indexing. And basically, for the email, we're saying free morphism plus debwiki gmail.com. If you want to email me, but use your own name instead of debwiki, I will actually answer email, believe it or not, because I don't have to read it, custom, I don't have to be spelled by hand, while still being able to fully operationally inhabit the functional behavioral equivalence classes of those who spend their lifetimes doing this. So it's kind of like a beautiful time to have been a procrastinator and learning some bullshit that you didn't feel you were doing anyway. Okay, my terminal is crashing. The